determine the types of search terms that consumers are using, and then we can match that back to the HCP and the requirements there. So there's a kind of a synergy between those two.
Yeah. And how do healthcare professionals use that then? So if you're a healthcare professional watching here, you are sitting in your office, you've got a pile of patients waiting to see you, how could they use it to their benefit, do you think?
I think that's quite a broad question. I think you have to look broader about. You have to define what we mean by social media. Mm-hmm. So I think the kind of the rise of AI and the use of AI and artificial intelligence within kind of mobile and kind of desktop environments means that there's a way to automate some of the answers to the questions that parents might be asking about their children. Mm-hmm. So I think there's a kind of a growing number of ways that we can use artificial intelligence and social as a way of answering some of the kind of more fundamental, mundane questions that might have usually been blocking some of the HCP time.
I think especially when the science of something is really clear, then something like an AI bot, we'll all have used them when you've... Yeah, so if you've gone on, say you're having a problem with your internet and you go to your internet provider's website, a little window might pop up in the corner and it asks you a couple of questions. That's probably automated, and it knows that there are maybe a certain kind of set of questions that people are going to immediately ask when they have a problem, and it'll take you through a bit of a triage. So, is it plugged in? Have you turned it on and off again? That sort of thing, because those pathways are really clear. And so on topics where the science is really clear around some basic things for kids, then that kind of automated question and answer can work really well. I think where it gets challenging, and where healthcare professionals, they certainly tell us when we're doing surveys and conversations, that there are a lot of areas where it's not quite so clear. So there's lots of choices parents can make around a certain, we talked yesterday about structures in a day and the kind of habits that you lay down for a child. Well, it's unique to the child and the family. So Facebook won't tell you what to do, Google won't tell you what to do. So they're still coming into their doctor and asking, which is best? Well, the answer is neither's best. I think 10 years ago, 15 years ago, that parent might have gone in having talked to their mom and their neighbor. Now they're going in having talked to their mom, their neighbor's cousin, 10,000 people halfway around the world, reading a whole bunch of chat rooms, and then going to Google, Dr. Google, and they come in with even more confusion.
So what is trending at the moment? What are the trendy topics on social media around, I guess for us it's nutrition, brain, cognition. What are the trendy things we should be looking out for now? And for healthcare professionals, what are parents asking about?
Yeah, so when it comes to food and nutrition for kids who are probably a bit older than infants when they're starting to eat, so parents are searching for the same kind of things adults are searching for. So they want to look for organic. They're looking, they're using terms like sugar-free, GMO-free, natural, chemical-free. So the same kind of wave of eating healthy that you see in the sort of mainstream nutritional world for grown-ups. Parents are looking for that for kids. We spoke to a couple of folks yesterday about the rise in sort of vegan or vegetarian diets for kids, and there's quite a lot of controversy about that because it may not provide a complete nutritional sort of spectrum for them. But that's a huge trend in social searching right now for parents.
I think one of the things that we're asked for in kind of the scientific side is the gut-brain axis, because that seems to be emerging science coming on gut-brain. Is that something that you're seeing if you look differently at maybe healthcare professionals, social media?
I haven't seen it. I don't think we've really looked that closely at those kinds of topics yet.
I think you would have to, the way you would analyse that type of sector, you would look for the search terms that HCPs will be using, and then you'd aggregate up and kind of drill down into the actual specific topics. So it's kind of, you'd have to monitor over a specific length of time.
Yeah, there's definitely some emerging conversations around sort of infant and young child's well-being. So a real swing away from, we talked about helicopter parents yesterday, and there's actually been quite an interesting shift we're seeing around wanting a child to be happy as well as successful, and parents looking for just advice, information about how to strike the right balance. So we know that can be, it can be quite a cultural set of questions, but parents in all the places that we've looked are trying to find ways to give their child the best start and help them compete and ensure that they're still doing well, but also helping them feel less stressed, less pressured as a young child. So you see that through social as well.
And has that changed over time then? You've seen that wasn't such a strong trend a year ago, or how long has that taken to emerge?
Yeah, probably more than a year.
I would think so. I mean, the term helicopter parent has been around for quite some time, and I think as you go through probably the decades, I think probably every decade we'll have the same conversation. This time, the moment now is different for my child than it was in the past. So it's kind of quite difficult to really specifically say when a particular trend starts. I think the kind of the health and wellness movement's kind of quite an interesting one. And I also think we do project we project kind of probably more adult themes than the ones that we would talk about on a daily basis onto our children. So that hence the rise of veganism or plant-based, or there's certain buzzwords that are lenses that we would apply to our own children.
Yeah. Another interesting aspect of sort of what social media brings to the healthcare professionals world when they're relating to parents is that parenting is changing and families are changing. We see more dads getting involved, more carers getting involved. Multi-generational families have always been something around the world, but those multiple generations are now all online and they're all looking for information or sharing stories about kids. So the kinds of people who are searching is a bit different than it probably was a decade or 15 years ago, and that's quite interesting because dads would be looking for maybe different information than a mom would be looking for, and they're more likely to be taking their child to the doctor's appointment. So for a healthcare professional, that might be a new kind of language they have to learn about the concerns of a really engaged dad who's kind of striking out in a new way, and those dads are a relatively sort of new generation, and I don't think healthcare professionals have had that a lot before, which is great and certainly a wonderful thing, but it presents challenges around, again, time and the kinds of questions you need to answer.
Sure. Well, thank you very much for this insight. For me, it's opening a whole new world. Hopefully, after the last couple of days, executive functions will be the trending
the new topic.
The new topic. So we'll finish there. Thank you very much, Jim and Elise, for your insights there.
Thank you.
So we're going to take a short break, and we'll come back in roughly 3 minutes with Professor Sean Dioni, who's going to give us a fascinating insight into the inside of the working brain. So thank you. So welcome back. Welcome today to our Nutrition, Brain and Cognition, the second day of our fascinating program into the inner workings of the brain and brain development and how nutrition can really impact on that. So it's a great pleasure to introduce you today to Professor Sean Dioni. And it's really a change up, I was going to say, from yesterday. Yesterday we talked a lot about kind of basic science and how executive functions work, how we monitor them, how we measure them. Now we're going to take a delve into the brain with Professor Dioni. But first of all, I think we'd like to get to know a little bit more about you, Professor Dioni. So I know you've come a long way to be here today, so thank you very much. But how did you get to being this professor in your particular field? What's your journey to here?
Yeah, no, that's a good question. It's a very non-linear path, as it were. So, so by way of sort of brief introduction, obviously, so my background is actually an MR physicist. So way back in the day of actually designing ways of actually acquiring data and trying to tease out more information using magnetic resonance imaging, tease out more information from that signal that we acquire to really get a better understanding of brain structure, brain function, and what was going on. And that was originally actually predominantly done for neurological disorders like Parkinson's, essential tremor, and the like. We then got interested in psychiatric disorders, and I undertook a postdoc in the UK to sort of begin to take some of those imaging methods and apply them to understanding really the neurogenesis or the early origins of psychiatric disorders, things like autism, ADHD, dyslexia, schizophrenia, psychosis, etc. But at the time, most of those studies were really in adolescents, older children, adolescents, and adults. And we have this theory that all these disorders have their genesis, as it were, in infancy. And so there was a lot of work then that kind of came back to the physics development side of things to really bring those methods and push them down and start to look at infants. Then, of course, once we got into imaging infants and getting data from those kiddos, there became a question of, well, how do you compare them? We don't really know what normal is. So that was the first approach when we started at Brown, was really trying to understand what is normal development? What does a healthy, typically developing brain look like? And of course, once you start to delve into that, you realize normality is very difficult to characterize. And so we started understanding, or needing to understand, the influence of all these various environmental exposures that we experience. So things like nutrition, things like your family environment. And so that's how we've kind of gotten to where we are now, which seems a million miles away from where we started, but the central key thing being this large magnet that we get to play with and try to put kiddos into and get really the striking looking images and really understand the brain. So that has been central to everything, but everything else is very much meandered like a stream. So, yeah.
So you kind of mentioned normal brain, and actually we had a lot of questions yesterday from healthcare professionals. What does a normal brain look like? Are we close to answering that question, or is there no such thing as a normal brain?
I think we're probably, the hope was for the former, and I think the truth is probably closer to the latter. So, I'm kind of almost amazed that we're all pretty much normal, functioning people, actually, given the complexity of the brain and its varied abilities to adapt and change. So, I think there are certainly functions and general overall patterns that are probably similar between individuals, but we're all very, very variable, which is a good thing, right? It allows us to be different and allows us to do different things. So I think we're getting close to understanding at least those core functionalities, but I think we're also getting close to understanding that the greatness of the brain is in its plasticity and its variability, and the ability to remap things and to change things, which makes it difficult for scientists like us to understand, how to alter things, but also makes it really great because it means we can alter things. So we're never on a defined path. We can correct course, which is healthy. It's good.
So how did you get into nutrition? I guess it is, I know you talked a little bit about the modifiable factors, if you like, for brain development, but nutrition seems to be a little bit of a leap. So how come that you found that it's so closely related?
Yeah, so again, coming from a physics background, it's the last thing that we would think of, but really it was one of those sort of serendipitous moments where we'd been acquiring data on a pretty large cohort of kiddos, and acquiring a fair amount of medical history and family history information on those children. And we came into the lab one morning, and another group, I think in Ireland or something, had published a paper looking at early exclusive breastfeeding and later cognitive outcomes. And I was like, well, that's kind of interesting. Do we have any information on that? So I did a quick Google search on what has been done in the imaging field, and pretty empty. There wasn't a lot there. There are some studies of early breastfeeding, and then again this imaging in later adolescence, because the kiddos are pretty challenging to scan. But there was nothing. So then I ran out to my research coordinator and was like, do we have information on breastfeeding? Do we have any of that information? It's like, indeed we do. So yeah, we started looking at that, and within about 2 or 3 days, we'd kind of crafted out this interesting story about differential brain development patterns associated with sort of exclusive breastfeeding, mixed formula breastfeeding, and then formula feeding, and that kind of then led into the whole work working with other colleagues and scientists about looking at is it breastfeeding itself, in the sense of is it the composition of breast milk, is it the nutrients that are there, is it the actual act of breastfeeding, so all the bonding that kind of goes on, so you have the psychosocial element, or the combination too, and so now that's opened up a whole new field. So now we're headed down into that path. Which has then brought us into other areas of adversity and whatnot. So again, it's been one of those things that's been meandering in a very nonlinear path. Certainly a path of personal growth. As a physicist, I wasn't able to say the word breast for most of my adult life. So having to get over that and give talks on this was a bit of a challenge, but certainly something that was interesting. So yeah.
It's really interesting because when I did my PhD, we were taught, or we learnt, that the brain is quite structured and not dependent on external environment, not dependent on external factors, that the brain is conserved at all costs by the body.
Right.
So to find that it's manipulated by nutrition is actually quite a big finding. Was it a big aha moment for you when you were researching the innermost parts of the brain?
Yeah, absolutely. I think it's one of those things where, again, it's probably one of the easiest modifiable aspects, right? And certainly when we start to move into more adverse environments, so moving away, say, from North America, or into certain areas of North America, or then moving into other areas of Southeast Asia, Sub-Saharan Africa, where you have other problems going on, can you actually use nutrition to help drive that? Or it's something that it's one of those potentially low-hanging fruits that we can do that might have a positive impact. So yeah, it's definitely sort of one of those, that's fantastic. On the flip side, there's also these are big challenges. So, but yeah, so again, this sort of yin and yang imbalance. But I think, yeah, definitely sort of, again, mind altering in the sense of we can actually do something. We can change something, which is
powerful.
Yeah.
So you've seen the innermost workings of the brain by looking at the structure and function and anatomy. So when people who aren't in your field, who aren't in your scientific area, people that you meet maybe socially, what do you tell them that you do?
Oh, that's a good question. Well, I think my mom was most pleased when I became a professor, because then she knew what I did, right? So that was easy. We take pictures of kids' brains, right? So really, I think it just comes down to just saying that we try to understand what is a healthy child, what makes a healthy child. Unfortunately, I think the best answer we have to that question right now is just love your child, which doesn't require a large magnetic in a scanner, but just trying to understand that, and trying to understand how we can help contribute to the world in a way that helps kids live a very healthy and productive life. So I think we can do that.
So I don't think we could say it any better than that. So on that note, we're going to take a couple of minutes break and then come back to listen to Professor Dione talk about the lessons learned from the studies he's just outlined to you, and we'll be taking questions later. So thank you very much.
All right. Well, welcome back to Brain Stories by the Fireside, as it were. We're going to be talking a little bit about, as we talked about before the break, some of the lessons that we've been learning in some of our neuroimaging studies that we've been doing at Brown University, which is in the United States, on the east coast of the United States. So I think over the last several speakers and a series of speakers, one of the themes that has kind of emerged really is this importance of looking at the first 1,000 days of life. So really thinking about, what is the importance of the early life period on overall brain development, cognitive outcomes, school performance, etc. And what can we actually do during that time period to really sort of optimize that child's health for those outcomes. And if we think about those first 1,000 days in a very visual sense, I mean, this is really what we're talking about, right? So we have a baby there, it's about a day old, and our older brother who's just over 2 years of age. So that really is the postnatal aspect of the first 1,000 days. And just think about all the various changes that young girl is going to experience in her life as she grows up to be to get to the same age as her older brother. So thinking about she's going to learn how to roll over, how to crawl, how to walk, say some of her first words, begin to understand how to manipulate her parents to get what she wants, all sorts of things that she's going to be able to begin to do and learn. And of course, all of those cognitive functions that she's learning, and that we've actually heard from several speakers previous to this, all those behaviors, all those cognitive functions are not surprisingly being mirrored by complex changes within the brain. So if we just think about what's happening both in fetal development and again over those first 1,000 days, those first 2 years of life, there's tremendous change going on in the brain. We have obviously changing cortical structure, so that's the gray matter around the periphery of the brain, changes within the structure of the brain, changes in the architecture of the brain, how different areas are wired up together, and then also exemplified by that just changing white matter maturation. So you can see that change in the white gray matter areas between the two, between those series of images. And we can quantify those and really get a sense of just how important those first 1,000 days or 2 years of life are to overall development, again, by just sort of characterizing these. So if we're looking at, say, 3 big gross anatomical changes, so things like your just total brain volume, your brain growing, things like cortical thickness, which is, again, that thickness of the gray matter around the periphery of the brain, which is a measure of how many synapses you have in those areas of the neuronal density, and then myelination, which is really that change in white matter that you saw, that change in hyperintensity. And just looking at those curves in this case, over the first 5 or 6 years of life, but then drawing that line down, which is at age 2, you get a sense that there's a tremendous amount of change that's occurred in that brain by the time that child reaches 2. You're basically reaching about 85 to 90% of adult level values by the time you're 2. So again, this idea that those first 2 years of life play a really important role in setting your path, setting your trajectory for later life outcomes is not really hyperbole. It's sort of written in the data, as it were. And one of the key neurodevelopmental processes that our lab has really been focusing on is that one that's on the right there, that myelination, the maturation of the white matter. And the reason that we think that is important is if you sort of think of your brain being like a computer, you have all the processing going on in that outer ring, that outer cortex, the gray matter. But what is wiring all those areas up is all these little white matter fibers. And they act as the lines of communication between each thing. And you can imagine, if you sort of think about ourselves, so myself being one gray matter region, maybe yourself being another gray matter region, and we have to have this conversation, we have to have information flow back and forth between us. And if I start, then you don't really what I'm saying, right? So that communication is just as key as our ability to process that information. And that communication is really being carried by that white matter. And around what sort of facilitates that information processing in a rapid and coordinated manner is this process of myelination. It is literally a wrapping of a fat layer around your neurons. So if you took each of those little strands, and to get a sense of how big those strands were, if I were to go and pluck one of my hairs out and lay it on its end, I could actually fit 50 neurons along that axis of that hair, right? So very, very thin layers, thin wires that line up that connect your brain. And along those is how information gets transmitted between different regions. And when we're born, and we don't have anything along those lines, we just have those wires, information travels very much like an electrical wire, point by point by point by point. But as we get better, and as we learn things, and as we develop, we lay down this sheath, this fatty layer sheath, which we call myelin. along those axons. And now, instead of information traveling point by point by point by point along that axon, it now hops like a kangaroo or a rabbit along that axon. And that allows speed to increase by 10, 100, even 1,000 times faster than in a non-myelinated axon. And so that allows information to travel throughout your brain in a much more rapid and coordinated manner. And this process occurs in a very characteristic fashion that lines up with evolving cognitive function. So we have areas, for example, we have this sort of center out, back to front in the brain maturation pattern. So we start off with things like your visual cortices, moving up into your motor cortices, out into your language, etc. So you have this very characteristic time pattern that occurs. And this maturation then of this white matter, which allows information to flow more rapidly throughout the brain, means that our brain becomes more complex. When we start off and we think about neuronal architecture, information is really processed very, very discretely in different regions in your brain when you're very young. But as we get older, those neuronal networks become more complicated, they become more integrated, and they become more distributed across the brain. So we start to process information from different regions of the brain, allowing us to do more complicated things. But that is all driven by the ability to transmit information across those larger distances without delay. Okay. So this, hopefully that brief introduction has kind of laid down the importance of understanding brain maturation, and in particular white matter maturation. But there's some pretty key questions that we want to kind of delve into. The first one is really, what is that typical pattern of brain development in myelination? Most of our data that we have on myelination in particular comes from histological studies that are 100, 150 years old. Right? So not a lot of information in typically developing healthy children. The next stage then is how does those processes of development relate to cognitive performance? What is that relationship between structure and behavioral cognition and function? And then, of course, coming back to the role of nutrition and other environmental exposures, is really how does the environment affect those relationships? So if we think about this in a mathematical sense, this is really sort of a mediation. So we have environmental exposures perhaps alter neurodevelopmental patterns which have an impact on your cognitive or behavioral outcomes. But we really don't understand that whole chain of events. And so that's really what we've been looking at. And when we think of environmental exposures, those are quite broad, right? We obviously have nutrition, which is a focus of today, but there are numerous other exposures that we're interested in. Your family's income and socioeconomic status and other indicators, overall stress within the family, sleep health, activity, maternal health care, all sorts of different environmental exposures that we experience on a day-to-day basis. So that's what our work has really been focusing on. And of course, we've been trying to think about, well, how do we actually go and measure all these processes? As I say, most of our information that we have comes from histological data, but of course that requires a pretty invasive approach to get that data. So we don't want to do that on our kiddos. So instead we've moved to these large medical devices we call magnetic resonance imaging. So basically a large magnet that we put you in and get some very beautiful images out of. Those typically are a bit challenging, right? So if you think about putting these little children, these little monkeys into those big scanners, they tend not to go too well together, typically because you have to lie very still for long periods of time, be very quiet, all of which children are biologically incapable of doing. But nonetheless, we can, number of processes to go through to have them fall asleep naturally in our center. So they come in at around normal nap time, they fall asleep, we move them into the scanner, start to scan. We've done some work to quiet the scanner down, and we can get some beautiful images. And when we put that data together, for example, these are some of the series of data that we can get. So this is just looking at overall brain maturation from about 3 months of age up to about 5 years of age, and just looking at the various changes. So at the top there, that top level is a measure that we have that is very sensitive to that myelination process, that myelin content. And so you get that idea of how that maturation occurs. And again, it's in that center out, back to front pattern over the first 2-3 years of life. And then we have some other contrasts that also provide information as to how this brain is structurally developing. We can then go and relate these things to overall outcomes. So for example, we can look at overall patterns of development and how do patterns of development line up with overall outcomes. So here, for example, we just took children that we had measured IQ on when they were 3 or 4 years of age, and then looked backwards at how their brain was developing previous to that. And you can get this idea that looking again at this overall process of myelination, you can begin to see differential patterns of development. And then we can relate that down even more specifically, say, for example, what areas are developing that are predictive of motor function performance, or of visual function performance, or of language. And again, really trying to understand the architecture of the brain and what areas are specific to different functions. We can also look at something that we call asymmetry. So the brain, although it is two hemispheres, do not necessarily develop in a coordinated manner. Some areas and some functions are located on one side of the brain and less so on the other. And so these, again, are areas where we have differential development in myelination that is associated with different cognitive performances. So in this case, receptive language and expressive language. So your ability to hear and understand someone talking to you, and then your ability to talk back to them. And so you get this the ability to predict performance, even in younger children before they're actually able to begin to develop words. They are understanding language, and they're developing that ability to express themselves. So if we think back and coming back to some of these influences that we are really interested in, we can begin to think about, well, if we want to understand the actual impact of adversity and environment on the brain, then sometimes we need to get out of our lab, sometimes we need to get out of our boutique in Rhode Island or in the East Coast of the United States and move to areas where there is extreme adversity, right? Look for extreme cases of environmental exposures. And so we've been undertaking a study over the last several years in Uttar Pradesh, India, which is in a northwestern portion of India, which unfortunately has some of the worst child outcome and developmental characteristics on the planet. It actually accounts for about 1/5 of the world's stunted children, so malnourished children. And we've taken all of our techniques that we've developed in the US and brought them over into this area and worked with a team there, an amazing team in Lucknow, scanning children there. And one of the first things that became very interesting here was if we were just to take, say, overall patterns of brain development. So again, this is kind of going back and just looking at overall white matter development, so sort of a surrogate measure of myelination. And looking at that between males and females in our high income setting, our Providence, Rhode Island setting, we do see this differential between boys and girls simply because boys and girls' brains are different sizes, because boys and girls are different sizes themselves, right? Males tend to be a bit bigger than girls. But we see that there's not a huge difference between the two. Suddenly, if we go and look at that in the India population, we begin to see a much greater disparity between these two, right? So there's a huge difference between boys and girls. So this kind of gives you some insight that possibly environment is playing a really significant role on these kiddos. You might say, though, but hang on, children in India, in particular boys and girls, are of different size. So maybe this is just simply due to the fact that they're a bit smaller, right? Their heads are a little bit smaller. Well, so we can normalize for that. We can go back and we can normalize for overall head circumference, for example. And certainly in our high income setting, our Providence, Rhode Island kiddos, that normalizes the boys and girls. They fall perfectly over top of each other. But that isn't what happens in India, right? So again, we have this difference between boys and girls is preserved. And again, kind of gives us some insight that there's adversity that's going on, but it seems to be differential between boys and girls. And I'll just draw your attention to one little point here. So if we just drew a single line here, you can get a good sense of what actually the impact of the environment is on these kiddos, right? So even if you look at the best possible male in India, are still significantly worse than what we have in our high income setting. So what's driving this, right? What are the various environmental influences that are driving these pretty profound and extreme differences in brain growth and brain development? So again, if we come back to these large, sort of broad scale aspects and influences, the one that really sort of stands out and has probably been investigated the most is probably the easiest, right? Is family environment. What is your family environment is? And more in particular, what is your family's income, right? Looking at disparities in income. And we can pull that down a little bit further and look at, say, well, what's related to income and things like education, right? So educational outcome is always a big predictor. Let's look at that. And so if we, again, go back and we look at whole brain white matter and myelination in a high maternal education, so this is looking at how many years of education your mother has, versus a low maternal education. So this is basically college and up, so college, university, or professional degree, doctor, lawyer, etc., or lower, so high school to college and below. And so the two things you begin to see very immediately is, one, there is a differential developmental pattern in white matter development and myelination that might be underlying the developmental differences we just were seeing in our India cohort. But also those differences are in math. And again, we can go back and we can look at very early changes in the brain development and overall brain patterns to see, can we begin to pull out those kiddos who are doing very well later on versus those kiddos who are doing a little bit more poorly. And so here, for example, are just two brain regions that we pulled out that seem to separate children who have very differential performance in spelling, letter, words, and reading. We can also do that for mathematics. And again, pulling out areas where differential brain development was very predictive of how that child was doing in overall mathematical performance. Now the question is, do those relate back to some of our early indicators of family environment? And indeed they do. So if we go back and we do that actual mathematical mediation, we can link these things up. So we can look at things like maternal education, breastfeeding, etc., link that to the cortical development rates that we just saw, which then link to our cognitive abilities, our overall childhood outcomes. So this is quite interesting. We're actually now taking early predictors, say breastfeeding over the first 3 months of life, relating that to overall cortical developmental profiles over the first 8 years of life, and then linking that to overall mathematical abilities in later life, 8, 9, 10 years of age, right? So again, getting this sense of how well do things that you do very early in life affect longer term outcomes. Okay, so what you do early on does matter, but also you can change it, which is a great thing. So I think just some take-home comments from all of this data that we're kind of trying to summarize quickly and pull together is really that infancy and early childhood are really critical periods of brain development. You know, there's a lot that's going on. You're reaching 85 to 90% of brain volume, brain maturation by the time you're 2 or 3 years of age. And this obviously can have very lasting impacts on a child's cognitive and academic growth. Brain development is a very complex process. We have a number of environmental influences and genetic influences that shape and affect that brain development patterns. And the great thing is that many of them are modifiable. Some of those include, for example, early nutrition, so breastfeeding. These things can positively promote brain health. So breastfeeding, reading to your child, holding your child, and in essence, loving your child can positively promote brain development. And of course, that this positive brain growth is associated with improved cognitive development profile and of course, later school outcomes. And bringing this back to some of the processes that we've been interested in over the last couple of days, thinking about things like early executive function, particularly working memory, attention, inhibition, those areas that we saw associated with improved mathematical and reading outcomes are exact areas that overlap onto areas that we know are involved with executive function. So if we were to probably redo our analyses just substituting in measures of executive function, we'd see the exact same profile. So we would end up getting now almost increasing our chain of events where we'd have early environmental exposures linking to executive function performance, linking to school performance, as outcomes. So with that, I'll leave it there and take any questions that you might have. So thank you very much.
and welcome back to everybody on the live stream and watching on the Wyeth Nutrition Science Centre. And it gives me great pleasure to introduce to you Dr. Ryan Cavallo. And this opportunity now is really to get to know a little bit more about you, Dr. Cavallo. Not the science behind what you're going to talk about in a few minutes, but to know a bit more about you. So what would you like to tell everybody watching about yourself?
Okay, so that is a hard question. But I'm a pediatric gastroenterologist. I have had the luxury and the privilege over the years to work with children, infants, toddlers, preschoolers, adolescents, and their parents and caregivers. And what that has taught me is that compassion is key when you talk about pediatric care. And all parents really want what we want for our own children, and that is for them to be the best people they can be. And it's about connecting with parents and understanding what their need states are, and then to share with them information. The biggest learning I've seen in my career is that there's been a change in how we practice medicine. From a time when we would walk into a clinic room, ask questions, and then just make a recommendation, to now actually having a dialogue with parents when they are as integrally involved in their child's care as we are. So I love that this paradigm has moved to, at the end of the day, some of us are parents, and we have a discussion as healthcare professionals with parents to all work together to give that child what we all believe they deserve, and that is the best they can achieve.
You're very interesting to us because you're a paediatrician and a scientist. Very great interest in science, I know. So where did that come from? So tell us a little bit more about where you were brought up, where you studied, and why the real combination of pediatrics and science.
Okay, so that's certainly an easier question than the first one, but I was born and raised and went to medical school in Mumbai in India. And that's where I first realized the importance of nutrition, but more to actually use nutrition as a tool to prevent diseases like malnutrition, particularly marasmus or kwashiorkor. And then I had the privilege to move to the United States for my residency and fellowship. And when I was in my fellowship in the US, I actually had the privilege of working with really thought leaders in the School of Public Health, as well as in the Division of Pediatric Gastroenterology and Nutrition, where I was a fellow. And actually saying, you know, nutrition is just not meant to treat problems after they occur. But nutrition can be used to actually prevent problems before they occur. But more importantly, nutrition is a great tool to use to enhance the quality of life for a lot of us. Moving from a malnutrition paradigm to an overweight and obesity paradigm helped me see both sides of the spectrum. And what's really interesting is in a lot of countries across the world, they actually have the double burden. They have both malnutrition and they have overnutrition in the form of overweight and obesity. So nutrition has become really topical. It's always interested me because of where I came from. And I'm truly convinced that the more we believe in nutrition and the more we use nutrition in our day-to-day practice, the more we will move towards a paradigm of healthier lives and not focus so much on treatment, but more on risk reduction or prevention.
So do you learn a lot during your pediatric training? Is there a lot on nutrition, or is it something you've just developed an interest in?
So that's a great question. So as I said, because I was raised in India, nutrition problems were all around me, so I was cognizant about it. But in my pediatric residency, and there was probably a small amount of nutrition training, but I really benefited from doing a gastroenterology nutrition fellowship where I really learned. But the point you raised, Dr. Greenstreet, is so critical because I do feel, both as somebody who's passionate about nutrition and also as a pediatric gastroenterologist, that we really need to bring nutrition to the forefront of medical school education and residency education, whether you're a general practitioner, whether you're a pediatrician, whether you're a pediatric specialist, whether you're a midwife or a nurse or a pharmacist. I think the knowledge of nutrition is key. And I appreciate various resources like the Wyeth Nutrition Science Centre supporting these key initiatives of driving nutrition education to communities all across the world.
It's obviously something you're very passionate about. And forgive me, but I know the other thing you're very passionate about is your own family.
Yes.
And bringing your own family
Yes.
across the world.
Yeah.
So for a paediatrician, but also as a father, is it incredibly important for you to really understand the impact of nutrition?
So thank you for asking that question. And I feel very privileged to work in nutrition science and be a pediatric gastroenterologist. But what I'm most proud of is I'm becoming a parent and becoming a dad. And I have 3 young kids who are all in early childhood. They are 6, almost 4, and almost 2.
Wow.
And I've learned a lot about pediatrics because of them. I've learned that it takes a lot of patience to raise a child. It takes a lot of understanding to get a child to where you want them to be. But they've taught me so much about being a parent and a pediatrician. They've taught me the value of compassion and understanding, on how difficult it is to actually get a child to take a medication or eat the right food. And I've really enjoyed the experience, and I feel I've grown a lot as a parent, but grown a lot more as a pediatric specialist in talking to families and parents and other pediatric specialists on the role that we play, not just as pediatricians, but also as parents when it comes to raising children.
So you must have read a lot about the ideal nutrition
Yes.
for your own family.
Yes.
So do you try and drive that with your own family, and how successful are you?
So I do try and drive that, and I'm married to somebody who's also a pediatrician. So 3 things that I've learned is that don't argue about the science at home because most often I'm wrong or I will lose. Number 2 is I do try to bring in sort of the latest science into how you feed children and how do you get toddlers to embrace fruits and vegetables into the house. And sometimes they work and sometimes they don't. And the 3rd thing that I've learned is, at the end of the day, the science informs us. But the recommendation we give to parents has to bring in the real life scenarios that parents have to deal with every day and that pediatricians have to deal with every day. So science is key to informing the recommendations and the advice we give, but we have to take into account the real life scenarios where a lot of patients live and a lot of us as pediatricians practice.
Thank you for that. And I have one final question for you before we listen to Dr. Carvello's talk. You chose the title, The Facts of Life. It's an unusual title, so why did you choose that title for your presentation today?
That's a great question. So we know about the facts of life. It's commonly cliched in books and movies. And I feel like fat, particularly in childhood, oftentimes gets a bad reputation because of its association with overweight and obesity. But what dietary intake data has taught us is that when it comes to children, particularly young children, we know that dietary fat, particularly unsaturated fats, are a dietary gap. And that's why I call this the fats of life, because I want to raise the importance of there are different kinds of fats. Some are more important than others, and some are key to early childhood nutrition. And finally, because I'm talking about neurodevelopment, I always like to raise the point that the brain is oftentimes considered a fatty tissue, and I'll show you through my presentation the actual percentage component of the brain that's actually made out of lipids. And to bring it to life in a sort of funny way, I thought it'd be great to call it the fats of life.
Excellent. So thank you for clearing that up for us, and thank you for this discussion. I'm going to hand over to you now to do your presentation, and I hope that everybody is going to be asking their questions online, and we'll have some more time later to discuss the answers.
Great. Thank you so much.
Thank you very much.
Hello. Let's talk today about the facts of life in early childhood brain development. During this presentation, we'll spend some time to understand the importance of nutrition in the structural neurodevelopment and brain signaling in early life. We'll understand what are the specific nutrients that really make this difference. And while you've heard about DHA, lutein, and choline, in this presentation, we'll talk about phospholipids and sphingomyelin. And finally, what does the clinical evidence show us about the role of these nutrients in early childhood brain development? And as pediatricians, we'll end with talking about our privilege and responsibility on how we use this information to ensure that the patients we care for so deeply live long and healthy lives. What we know from the literature so far is that the brain is rapidly developing. As far back as the 1950s, we knew that the amount of neurogenesis and synaptic connections between the neurons was rapidly increasing in the first 6 months of life. But over the last few decades, we've learned so much more. We know that right from conception up to the first few years of life, the brain is rapidly growing and developing. And across the different phases of trimesters of gestation, birth, and in those first few years of life, different parts of the brain show different paces of growth and development. And this is critical because we know that nutrition provides a key benefit during these critical and sensitive periods of brain growth. The dialogue of nature and nurture has gone on for a long time. What we now know from science is that our genes expression dictates a lot of the early neurodevelopmental programming. What we also know is environmental factors can make a huge difference, and that's why reading, singing to children really helps with their neurocognitive function and early learning development. We know this from a neuroscience perspective through the concepts of experience-dependent synaptogenesis. But there are other environmental factors which play a role. Two key factors are socioeconomic status and nutritional status. In this data, you can see here that depending on whether a child was high, middle, or low socioeconomic status, the volume of the brain matter differed. But this tells you about the role that socioeconomic status plays. When we look at nutrition, there's data which clearly tells us that children who are malnourished have different volumes of gray and white matter compared to children who are more appropriately or not malnourished. But let's not forget the other factors which are also critical in brain growth and development. And these include social interactions. These include the ability of parents to interact with children as well as the environment where these children are raised. The impact of urbanization, pollution, social morbidities, mobilities, and stress really impact the various features that give rise to the child that we all take care of. You've heard in previous presentations the role that key nutrients like DHA, choline, and lutein play. Historically, we have all well understood the role that iron plays. But today, I want to spend some time talking to you about some of the newer evidence on the role of some of these key lipids, particularly phospholipids, which include sphingomyelin, phosphatidylethylamine, phosphatidylcholine, phosphatidylinositol, and phosphatidylserine. We know that these nutrients influence brain development and functions in different ways. They impact neurogenesis, oligodendrocyte growth, and the growth and generation of neurons. But one of the key learnings we've had in the recent past is the role that these nutrients play in myelination. And we know that myelination is one of the key factors that really helps transmit signals from the brain to the periphery and vice versa in a speedy and efficient manner. Brain connectivity is of different kinds and levels, and we know that nutrients are critical in this. Never to forget that genetics and environmental influences are key in the growth and brain development. So let's take a look at what we know is the best way to feed a child. When we look at breastfeeding and the many benefits that breastfeeding and breast milk provides to babies, one of those key benefits, which have been well studied and well described, is the role of breast milk and breastfeeding in optimal brain and cognitive development. What we know about breast milk is that human milk has a large amount of fat. In fact, 50% of the total energy of human milk is contributed through human milk fat or lipids. What we now know is that phospholipids account for anywhere from 0.2 to 2% of the fat that we find in human milk. And while there are 5 major phospholipids, which have been reasonably well studied, we know that 3 of them are more predominant in human milk. And these are phosphatidylethanolamine, phosphatidylcholine, and sphingomyelin, or a sphingolipid, and together they account for anywhere from 60 to 80% of the phospholipid component in human milk. The ones which are important, but not as predominant, and account for about 12 to 15% of phospholipids, are phosphatidylinositol and phosphatidylserine. Sphingomyelin has a critical role to play. From studies that have been done over the years, we know that it is particularly rich in the myelin sheath of the central nervous system, and is an important component to maintain the integrity of myelin and the function, and it also supports the maturation of the nerve cell axons. Both sphingomyelin and phosphatidylcholine, which we established are keenly predominant in breast milk, are key components of the human milk fat. What we do know is that the average content of phospholipids in human milk has a wide range, ranging from about 10 to close to about 50 milligrams per 100 ml. But what is really important to know, and the new information that we have now, is that it is estimated that for a 4-week-old breastfed infant, the daily intake of phospholipid can be about 140 milligram per day. What's also interesting to note is that some of these phospholipids can also be synthesized endogenously inside a baby. So we know they are present in breast milk, and we know that these lipids are a significant component of the total energy of breast milk. So what does it do for the baby in terms of brain development? Historically, we've known that the brain is oftentimes considered a fatty tissue. And this truth is actually scientifically proven because we know that lipids account for 10 to 12% of the total components of the various nutrients in the brain. When we look more specifically at a different brain composition of the different kinds of phospholipids, we know that in a 10-month-old, total lipids are a significant component of gray matter, white matter, and myelin. And these numbers vary with time, but the highest accumulation of these lipids in the brain occurs in early childhood. When we look more specifically at the 2 major kinds of lipids, the glycerophospholipids and the sphingolipids, we also know that they account for a significant percentage of the brain composition in early life, accounting for anywhere from 20 to 30% of glycerophospholipids to about 5 to 25% of sphingolipids as contributing to brain composition. When we look more specifically of some of the unique kind of glycerophospholipids and sphingomyelin as a predominant sphingolipid, these account for anywhere from 10 to 12% of gray matter to myelin and about 1 to 4.6% of gray matter to myelin in 10-month-old babies. The important thing to realize here is when you look at the percentage contribution of these phospholipids to myelin, which is a very important component of brain tissue and axons, you can see that the percentage of contribution to brain is very high in early childhood, raising the point that giving the child key components of phospholipids in early life is very important for their neurodevelopment and their brain function. So let's look a little bit more about the biochemistry of these phospholipids. We've known so far that phospholipids are a key component of the cell membrane. They typically have a hydrophilic part, which is on the top, oftentimes containing a polar group of lipids called as pololipids. This polar group could be phosphatidylcholine, phosphatidylinositol, phosphatidylserine, or phosphatidylethanolamin. And we know that they contain the sphingomyelin backbone, which is very critical for their integration into the cell wall. And due to this hydrophilic and hydrophobic nature, they play an important role in the development of cell membranes. And they are found in incredibly high levels in dendrites, the myelin sheath, the synapses, neural structures, and we know that these are vital for these important brain connections which are developing early in life. So when we look at a broad sense of what do these phospholipids do, broadly, they do three things. They help maintain the important structural integrity of the cell membrane. They really play a key role in metabolic pathways, which are related to and important for energy homeostasis in these cells. And finally, we are learning a lot more about their role in intracellular signaling processes as well as connections. While we know that broadly they do these three things, let's look more specifically at certain key functions we know which are very important to be developed in early childhood. We've spoken about the structural integrity of neural tissues and the role that they play. But they also have a key role to play in synaptogenesis and synaptic transmission. And this is where their role comes in myelin as well as myelin generation along the axons, where phospholipids are key for myelin biogenesis, for axon to glial cell communication, and for the long-term maintenance and the integrity of myelin. We know that peak rates of accretion overlap with key neurodevelopmental milestones, which ultimately drive brain connectivity for fast and efficient brain communication. So far, we've known that lipids are an important component of the brain. We've studied that the best way to feed a child, which is breast milk, has a high amount of lipids in human milk. 2% of those lipids could come from the various kinds of phospholipids. We know that phospholipids, particularly phosphatidylcholine, ethanolamine, and sphingolipids like sphingomyelin, are key components of brain tissue. And finally, more recently, we've actually understood what do they really do in the structural development of the brain, but also their role in functional connections in the brain. While we've known about all that, let's look at some of the clinical evidence which gives us reason to believe what we've so far studied about the role of phospholipids in brain development and functions. In this observational study, which was done in the United States, they aimed to examine the longitudinal trajectories of brain and cognitive development in children who were exclusively breastfed, as well as a cohort of children who were formula fed for at least 3 months. And they looked to see, is there a developmental difference both in myelination, in brain development, as well as function in children who were breastfed exclusively versus children who were not. Their population consisted of about 62 breastfed children and about 88 children who were formula fed. And what they found was really interesting and novel when it was published in the early childhood neuroscience literature. That exclusively breastfed infants had significantly improved myelination, as well as higher cognitive scores, which were described as an early learning composite, as compared to children who were not exclusively breastfed. When they did a retrospective analysis of the data, they found that certain nutrients showed a significant association with myelin content, and these included DHA, ARA, folic acid, but more specifically sphingomyelin and phospholipids, particularly phosphatidylcholine. So this observational data gave us reason to look a little bit further into the correlations that this study taught us between certain nutrients and certain brain development functions like early learning, as well as brain anatomy like myelin fractions. What was further interesting is that while we know there is a difference between children who were exclusively breastfed and children who were not, this study also taught us that the nutrient composition of certain formulas can also tell us about the difference that you see in the myelin fractions that are developed in the brain, as well as the early learning composite. And through a regression analysis, this data taught us that the quantitative myelin fraction in the brain has a linear relationship with the early learning composite score, telling us that it's not just anatomically important to have myelination, but this myelination has a functional correlation with early learning composite scores, which is a way to measure early childhood learning. And as we know from the retrospective analyses, that key nutrients like sphingomyelin, phosphatidylcholine, DHA, ARA, choline, and nutrients like folic acid and iron are key in terms of these nutrient components to early brain development. And while that was a very interesting observational study, which brought this to life in an anatomic way through myelination, and then the correlation between myelination and early learning composite, let's look at some of the clinical evidence that we have that have looked at this in early infant trials. In a pilot study that was done by Tanaka and his group and published in 2013, they looked to examine the effects of certain nutrients like sphingomyelin on the mental, motor, and behavioral development in premature infants. They used a randomized, controlled, double-blinded study as an ideal design to look for the differences which could be attributed to these key nutrients. They had 24 very low birth weight infants, less than 1,500 grams, who were predominantly breastfed, and what was not meeting their nutrient requirements was supplemented with either a formula which was fortified with sphingomyelin or a control. And they were followed for up to 18 months. The outcomes they measured was mental, motor, and behavioral development. The first thing they looked at is whether providing sphingomyelin really made a difference to these babies. And they measured the red blood cell total phospholipid content. And they found that the percentage of sphingomyelin in the total phospholipids in these red blood cells was significantly higher in the sphingomyelin-fortified group than in the control. And then when they looked at the outcomes they hoped to measure, behavior, cognition, and visual test results, they found that at 18 months, outcomes were significantly better in the sphingomyelin-fortified group than in the control. So they concluded in this study that very low birth weight infants, a nutritional intervention with the sphingomyelin-fortified formula, has a positive association with neurobehavioral development of these infants. Another study that was done looked at 3 groups. They looked at term healthy infants, about 160, 80 male, 80 female, who were randomized to 2 groups. They either received a formula which contained a phospholipid complex or a control formula. The third group was a breastfed cohort. They were fed the intervention between birth and 6 months of age, and they evaluated these children for neurocognitive outcomes at 12 months of age. What they found was when looking at outcomes, they found that cognition was significantly higher in the infants who received the formula containing the phospholipid complex as compared to the control formula. The infants who received the formula containing the phospholipid complex was also closer to the most superior way to feed a child, and that was the outcomes in the breastfed cohort, showing that breastfeeding is the best way to feed a child because of the lipid components and the various components of breast milk, which include things like phospholipids and sphingomyelin. But for the infants who cannot be exclusively breastfed, there are opportunities to consider with components that really help improve some neurocognitive outcomes related to cognition, as this study taught us. So finally, as pediatricians, what do we do with this information? One of the best privileges and responsibilities we have as pediatricians is to leverage the latest science, evaluate it, to help our patients make informed decisions. The responsibility that this gives us is that in the first 1,000 days, particularly in the first 2 years of life, is the most number of times that infants and toddlers and their families interact with pediatricians. And this gives us the opportunity to bring science, evidence, to have an informed conversation with parents when they make early childhood feeding decisions. So I want to end by saying thank you to all of you for giving us the opportunity to share this data with you. And finally, to thank you for what you do to improve the lives of children every day to help them achieve what we and their parents want them to grow healthy and happy and maximize their full potential. Thank you. Hello.
So good morning everybody and welcome back to Nutrition, Brain and Cognition. And this morning it gives me really great pleasure to introduce you to Dr. Mutungi, who is also a friend of mine. So we're hopefully going to get a little bit more information out of what makes Dr. Gisela Mutungi so interested in nutrition and brain development. So good morning Gisela, how are you today?
I'm wonderful, thank you. And you?
Good, yes, good. Thank you very much for joining this Congress. I guess the first question I'm going to ask you, which I've asked other people, is why are you so interested in nutrition? What's the background to Dr. Mutungi? Why are you here?
Wow, that's a lot of question. I'm interested in nutrition because I feel like there is so much that we still yet do not know about nutrition. And nutrition in terms of diet, it's very accessible in most cases. But unfortunately, we don't have enough information into understanding what we get from our diets and how that impacts our overall health. And in this case, nutrition and brain is, I think, a very interesting topic to me because it's fascinating to know that what you eat would impact not only your overall health, growth and development, but also impact your brain. I mean, it's not long that we connected nutrition or diet with brain. So this is really interesting to me to hear people from different fields talking about the connection between nutrition and brain and ultimately cognition.
Never forget cognition.
Oh, yeah.
So tell us a bit more about yourself, your background, where you're from, your kind of PhD, that kind of thing.
I am from Tanzania in East Africa, and my interest in nutrition started at a very young age because as most people would have known, in third world country we have an issue with malnutrition. And for me it was fascinating to know that there is a health condition that could be purely prevented by diet. So that's what started me in the journey of really trying to understand how nutrition impacts health and what are the things that we may do or we may learn that will be able to allow us to prevent aspect of unhealth situation just with nutrition. So that's kind of where my journey started. I did my undergrad in the UK where I focused my studies in both understanding food and nutrition as a whole. And then from there I moved to the US where I did my grad work, and my main research was really looking at DHA and pregnancy. And with this, it was very fascinating because it was amazing to see that by just modifying one component of supplementation, you're able to see aspects of nutrition that are linked into cognition. So then that kind of like made me realize that I did the right choice by following my dreams.
So DHA is, I know you're going to talk a little bit more about that in a few minutes, but there's lots of controversy around DHA. There's lots of information out there for healthcare professionals and for parents. So what about DHA for pregnant women? What's the current thoughts around that?
So I think DHA, like every other foods, you know, every other nutrients, is very important, not only for pregnant women, but for everybody. But for pregnant women, it's specifically sensitive because of the fact that it's not just their own well-being, but also the fetus that they're carrying with them. And indeed, they've been controversial because of the fact that the most rich source of DHA is marine foods. And it's been, you know, very well documented that there's a lot of pollution right now. And there's some incidences where some of marine foods may have toxins that may ultimately impact not only the mother, but also the unborn baby. But more and more data is actually showing that when you consider the amount of seafood that a mother would be taking, especially some types of fish, the amount of toxins that are associated with those fish is not detrimental to the amount that it defeats the importance of the DHA. However, at the same time, there's other things that definitely a mom can do to be able to get the DHA into their diet.
Oh, yeah.
Because in most cases, not everybody has access to marine foods. So there's other foods out there that have high sources of DHA that a pregnant mom can take. But ultimately, my biggest advice will be for pregnant moms to make sure that they talk with their healthcare professionals to be able to get the appropriate advice for them, given that they would have a little bit visibility in what their diet is like and be able to steer them into making sure that they're getting the appropriate diet during this sensitive and beautiful period of their life.
Thank you. So, Gisela, being an expert in nutrition, what advice do you give yourself, and what should we learn from an expert in nutrition? What should I be doing differently?
I guess I would call myself a passionate in nutrition rather than an expert in nutrition. Because, like I said, nutrition is a big, big area. So for me, I think knowing the value of food, knowing the value of the diet, knowing the value of what I put in my body is something that I try to remind myself every now and then. Of course, there's occasions where I'll probably indulge in things that I shouldn't that much. But
that's good for you too, right?
Yeah, it is good for you. I guess, as they say, too much of something may not be that great. So my advice would be really to be conscious of what you're eating. Try as much as you can to get access to more natural foods. Try to get access to vegetables and fruits in your diet. And, eat small portion frequently. And also, ultimately, don't forget to exercise as well, because that also has a big impact on your health.
You're doing so well right up to the exercise. But what about brain then? If we're specifically looking at brain, are there things that we should be looking at in our diets for brain development?
So,
is it different for different ages, for example?
So, it could, depending on how you look at it, definitely there are differences because of stage of life you are at. Especially early in life, we know there's a lot of things happening. The brain is developing rapidly. So the amount of nutrients and that you need would be a little bit higher compared to the body size as compared to an adult. But also bear in mind that there's a lot of body of authority out there that have already established aspect of nutrients that you need for different stages, taking into consideration what is happening at that stages. So definitely early in life, the amount of nutrients you would need compared to the proportion of the body size would be a little bit higher than when you're at a steady state where you're probably not developing as much, your brain is not growing as much. The amount of nutrients you need, that will be for maintaining the integrity and the function of the brain, versus also when you're looking at later in life where there is some decline in cognition as well. You probably need a little bit to pay more attention to what you're eating, because there's some nutrients that have been shown to potentially help with minimizing the acceleration of the decline.
Okay.
So being able to probably do a lot of things a little bit more optimal based on the age that you're in. So definitely diet does play a role, and at different stages, different amounts may have an impact.
So I think it's really interesting to talk to you and to hear about really how nutrition can really impact health. Not just learning, but generally health of well-being throughout the ages, really.
Yeah, it is a beautiful thing out there, because your diet is really playing a major role in your overall well-being, definitely.
Probably one last question for you, Gisela. Sure. When you were preparing for this talk, because I know you did a lot of preparation and read a lot of papers for this talk, was there anything that surprised you? Has science really moved on a lot since you did your research, or do you think it's just adding to the body of evidence?
I think the science has moved a long way because of the fact that the technologies that are available today, they were not available a while back. And in that case, as we get to learn more and more on the impact of nutrients in different aspects, including the brain, whereas before it was hard to really target specific nutrients and what potentially they could be doing in the brain. Now you have more and more high technologies that will probably be able to give us a little bit more explanation. Yeah, we know, for example, DHA gets into the brain, but what is it doing there at the brain? So now you get image data that probably will be able to shed more light to say, actually, this is what's happening, and the reason you didn't need this much, probably it's because the distribution is different at different stages and it's going to different places. So definitely not only the science has changed from the methodology part of it, but also the analysis of foods themselves, because depending on where you get your food, you can have the same grain, but that grain could potentially have different composition of food, and that definitely will play a role in that target population and where you are and what foods you're eating.
Oh, fantastic. And I guess just before you do your presentation, there's lots of questions we've already had coming in, so we'll get a chance to ask you those in a bit more detail, go really down to the science when you've finished. Is there a take-home message you want to give people from your presentation?
I think the take-home message would be we're, as much as we know today, we're still scratching the surface, because there's so much more out there that we still don't know. And every time we discover certain things, we're discovering more and more potentially what that is adding to our overall well-being. And when it comes to brain, there's certain components that are in the brain, but we still not yet do know what they're doing there. So this is just some aspect of me sharing of what's potentially right now out there, and giving you some suggestion of what has been speculated on the role of some of these components in the brain.
Thank you. So thank you very much, Gisela, for sharing a bit of your thoughts before your presentation. So now we're going to hand over to Gisela, and she's going to talk about DHA, choline and lutein in a lot more detail. Thank you again, Gisela.
Thank you. Good morning, good afternoon, and good evening, wherever you are streaming with us today. I have the pleasure of being here today and share with you a little bit of an overview on nutrition and brain development. And today my focus will really be on choline, DHA, and lutein. On this presentation, I'll be really talking about these components, meaning DHA, lutein, and choline, on their presence in breast milk. I'll also be talking about their presence in brain and eye, and potentially the roles that have been identified on these components in there, and also some of the scientific evidence that is available supporting these mechanisms. In breast milk, an omega-3 long-chain polyunsaturated fatty acid, DHA is found in ranging levels. It's been identified to be ranging anywhere between about 0.17% all the way to about 1% of the total fatty acid in human milk. And these levels have been really associated with the type of diet the breastfeeding moms are consuming. Whereas in high population where they consume marine type diet, the DHA levels can be as high as 1%, and this has been seen in areas like Japan. And then in population where the diet is low in DHA foods, the levels have been really low, including areas like Canada and US. The global mean level of DHA has been estimated to be around 0.32% of the total fatty acid. As you can see, this level is much lower as compared to the highest levels that have been reported so far, indicating that probably most population intake of foods is very low in DHA content. In breastfed infants, the level of DHA that they will be consuming will be varied, basically because of the fact that the amount of DHA in breast milk, as indicated earlier, is dependent on the diet that the mother is consuming. So for the kids that are born with mothers that are consuming high and rich food sources of DHA, their intake in breast milk will be higher, and vice versa, the kids that are born with mothers that have diet low on DHA, their intake will be a little bit lower. And then when we're looking at the amount of DHA in the brain, the accumulation is very high around the third trimester of pregnancy, and by birth, DHA is the actually predominant fatty acid in the brain. And the accumulation, actually acceleration, continues all the way through the second year of life. It's been estimated actually in pregnancy that the whole DHA total body accumulation could be as high as 50 milligrams per kilogram body weight. And in the brain, what is the DHA doing there? The DHA is known to be a building block for cell membranes in the brain, and high levels have been found in neuron synaptic membrane. This is an important area because it facilitates communication within the brain. In the synapses, the signals are transferred from one neuron to another, enabling the brain to have communication from one area of the brain to the other, making the presence of DHA in this membrane a very important factor because it maintains the integrity of this junction and therefore facilitating the communication aspect of the brain. And when we look in the eye, the DHA is the predominant fatty acid, especially in the retina, where in the retina it accounts for as much as 50% of the fatty acids, and these are mostly concentrated in the photoreceptor cells. And it's been identified that the accumulation of DHA in retina is very vital because it actually is optimizing both the maturation of the eye as well as the visual function of the eye. Data from animal models where DHA was devoid from the diet had demonstrated that there's detrimental effect on the retina which ultimately impacts the eye development as well as the function of the eye, indicating that definitely DHA has to be in the composition of the retina in order to facilitate the maturation and the function and overall health of the eye. And what do we know about the scientific evidence that is available on DHA? There have been extensive data that's been generated on DHA, and the studies have been both on randomized control trials, it's been cohort data as well as observational data. And in this instance, I will be focusing a little bit on early life, where there's a lot of studies that have been done looking at supplementing infant formula or some aspect of the diet for the growing child, and being able to demonstrate that by supplementing DHA into their diet, what was observed was that you're actually able to impact the cognitive aspect of the brain, where some methodologies have been used, including the Bailey, where they can be able to measure the cognitive function, including language development. And it was observed that when infants and young children are supplemented with DHA, their ability for developing language as well as aspect of motor function is more improved as compared to those who do not have access to DHA in their diet. Similarly, the data has been demonstrated on the function of visual, is the fact that DHA intake does actually impact visual acuity, whereas the vision of the child is more improved when they consume foods with DHA. And this vision is really tested where the stimuli on the visual is really connecting to the brain areas that are associated with vision. And it shows that with DHA intake, this stimuli is able to be transferred to the brain areas and then being able to isolate and being able to respond to the visual test that is being performed. And DHA has been regarded as conditionally essential, especially early in life, due to the fact that even though the humans are able to convert the precursor of DHA, alpha-linolenic acid, the conversion is very, very low. Given the amount of DHA that is required in order to meet the physiological need early in life, like I had shown earlier, you can see that DHA has to be consumed, preformed, in order to be able to satisfy those demands that are needed in a rapid development stage. And now we'll move to lutein. What do we know about lutein in breast milk? Lutein in breast milk has been shown to also be dependent in the diet, meaning that if the mother is consuming diet that is rich in foods containing lutein, then the breast composition of the lutein will be increased based on this diet. And data has been generated from different regions. Here I'm showing you data from Mexico, Philippines, and Oman. As you can see, the intake of lutein probably is much lower in Philippines as compared to Mexico and Oman, where in the Philippines, the breast milk level of lutein were about 15 micrograms per liter, which is half the amount that is seen in Mexico women, indicating that probably in Mexico, the diet that is consumed by these women has a lot of rich sources of lutein, therefore impacting their breast composition of lutein. What is lutein? Lutein is a carotenoid that plays an important role as an antioxidant. Hence, being composition in breast milk, that means it's providing this component to the infant to be able to help them with the aspect of an antioxidant activities that are required during development. So when we look at what is lutein or what is lutein doing in the brain or how it's been found in the brain, lutein has been isolated as a major carotenoid in the brain. And the data has been found similarly in infants, young children, as well as in adult population where the isolation has been identified from the brain. And in infant, it has been isolated in brain regions that are known to be associated with cognitive function. this has been isolated in areas that are known to influence hearing, areas that are known to influence actual aspect of memory, as well as areas that are known to impact language. So indicating that they're here and probably they may play a role in and facilitating some aspect of function of these areas. In the eye, lutein is found very high in inner retina, and this area is known to be very delicate and very sensitive, and lutein is potentially there protecting the eye because lutein has the capacity of absorbing potential damaging light, indicating that the light will be filtered before it gets to the retina, and therefore preventing it from harming the retina. And also within the eye, lutein is found very highly concentrated in areas that are high in lipid content, and this could potentially be a mechanism of that area being protected from antioxidant stress. Basically, oxidative stress can be prevented by antioxidant, and in this case, the lutein is there to ensure that this area remain healthy and it's prevented from any damage that may be caused by any oxidative output that is associated with lipid oxidation. The scientific evidence that is available, one of the things that is of interest, given that lutein cannot be synthesized in the body, so lutein has to be consumed with the diet. And it's been demonstrated that mode of feeding early in life may actually impact how lutein is bioavailable or how much lutein is bioavailable to the infant. Whereas when you compare with infants that are breastfed, where there is lutein in breast milk, you actually need a little bit more of the lutein to be incorporated into the formula in order for the infants that are formula fed to be able to have the levels of plasma lutein that is similar to those who are breastfed, indicating that more and more you probably see that you have more of the lutein in the formulas because of this data demonstrating that probably the matrix that lutein is coming in with breast milk make it more bioavailable as compared to the lutein that is coming into other form of the diet. And in young adults, there have been a study where a mix of lutein was supplemented to the adults that were between the age of 18 and 25. And what was demonstrated was by supplementing them with this mix, you're able to actually increase the macular pigment optical density of the eye. And in turn, this has also been demonstrated to improve the visual performance of this population, indicating that just because it's there, it also do have a role because of the fact that now you're able to have visual performance that is slightly better as compared to previously before they had supplementation and when the macular pigment was slightly lower. Similarly to this data, in subjects that are aged about 50 and above, when lutein was analyzed in either neurotissue or the test of macular pigment, it was observed that the levels of lutein in either the tissue or the pigment was positively correlated with cognitive function, indicating that there may be a correlation between the amount that is present in these tissues as well as the function that is associated with this tissue, giving more and more data supporting that it may not just be there for the protective part as an antioxidant, but it may also be there as facilitating some of the functional aspect of these tissues. And now we move to choline. Choline in breast milk does range, and it is been estimated that the mean levels is about 160 milligrams per liter. And also it's been shown that within the range of breast milk, there is differences between when you look at colostrum, which is the milk that is available between 0 to 2 days of breastfeeding. The levels are a little bit lower as compared to mature milk, indicating that the more and more choline is incorporated into breast milk as the milk matures, indicating that the breastfed babies will probably get varied range of choline as they go through breastfeeding. And this choline is a water-soluble vitamin with 3 main physiological functions, including being a component of the cell membrane. It also plays a role as a cell signaling molecule, and it has a major role because it is a major donor for methyl, and this is an important for methylation processes, and this is a driver of biological reactions in the body. What is choline doing in the brain? Choline in the brain is found to be incorporated in phosphatidylcholine as well as sphingomyelin, which are phospholipids. And these phospholipids are one of the major components of the cell membrane. In this incidence, choline is incorporated into these phospholipids, and it plays a structural role supporting the integrity and the structure of the membrane. Additionally, choline is a precursor to acetylcholine, which is a neurotransmitter. The neurotransmitter travels across synapses, transmitting signals between neurons, making the communication between the areas of the brain more efficient because of the fact that the neurotransmitter does transmit the signals from one area of the brain to the other. And choline does facilitate this by providing the acetylcholine as a neurotransmitter. What is the scientific evidence available showing choline may have a role in aspects of brain development? One of the studies had reported that maternal choline status in the first of the pregnancy is associated with later cognitive development in healthy born infants. This indicates that the choline playing a role in brain development potentially starts in utero, where the choline facilitates and helps the developing brain in order to really put in place aspects that will then be able to improve or facilitate the cognitive ability of the infants. In this cohort population, the maternal choline status was measured early during pregnancy, but however, the cognitive function of the babies were tested at 18 months later when they were born, indicating that there may be an association of that status of choline early during fetal development, which has carried the benefit all the way later in life and showing these benefits later at around 18 months of age. In toddlers, the plasma levels of beta concentration, which is a product of choline oxidation, have been also positively associated with better visual motor development, indicating that even by consuming choline, when it goes through the metabolism and it's oxidized, probably some of those metabolites also may have a role in influencing aspect of brain development. In these cases, you can see that in these toddlers, the beta levels were associated with visual motor development, indicating that those byproduct of choline may potentially be doing something and hence influencing aspect of cognitive development. And in adult and age population cohort, choline intake was related to better cognitive performance, meaning that in the population where the choline intake was higher, in these cases, the performance when they tested on cognitive outcomes was better as compared to those in the same population who had lower intake of choline, then providing more and more data indicating that choline does play a role in the cognitive development. And when we look at all of them together, DHA, lutein, and choline in the brain, as I initially indicated, lutein has been identified and isolated in areas of the brain that are associated with cognition. DHA is a membrane building block, as well as has been found highly accumulated in synaptic areas. And choline can be incorporated into phospholipids, which then are components of membrane. And it also is a precursor to acetylcholine, which is a neurotransmitter. They all seems to have some mechanism of which they're supporting probably similar areas of the brain for the for the function. And there is a cohort of breastfed babies that has reported an actual interaction between lutein and choline, as well as DHA and choline, where both with this interaction, it was observed that there was an association that was measured and influenced the memory of these children, indicating that potentially there is a mechanism where they work together to facilitate this function. All in all, adequate and balanced nutrition is critical to support rapid brain development, and this ultimately has a long-term impact on the cognitive ability. DHA supports brain and eye development and functional outcomes of this brain and the eye. Lutein is an antioxidant. It protects both the brain and the eye, and more data now suggests that it may actually have more than a protective role in these areas. Choline is a component of phospholipid, is vital for cell membrane, and has a role in cell signaling, eventually facilitating memory and helping with cognitive abilities. Ultimately, DHA, lutein, and choline are found in the brain and may work in complement or may work together to support its development and function. And both of these aspects are very vital when you're talking about cognitive ability, including aspects of learning, therefore supporting the ability to be able to learn and be able to perform and be able to function better. And as I indicated, definitely these are some of the nutrients that are supporting the cognitive ability, but definitely adequate and balanced full nutrition is important to support aspects of brain development and cognitive function. Thank you so much for this opportunity to be able to share with you on nutrition and cognitive function.
So welcome back to Nutrition, Brain and Cognition, brought to you by the Wyeth Nutrition Science Centre. We've had some fascinating discussions this morning and some great presentations from Professor Dioni talking about the innermost workings of the brain, to Dr. Carvalho talking about the importance of the fats of life, and finally, more recently, Dr. Matungi talking about the importance of really 3 key nutrients in DHA, choline and lutein. And unsurprisingly, there have been lots of questions that have come live through to the internet. So I'm going to start by asking a simple question, I think, Professor Dioni, and it's a question about sleep and the importance of sleep on really brain development.
Well, yeah. So simple in phrasing, not so simple in actual understanding. So, yeah, I think this is obviously something that has become far more relevant over the past probably decade as the number of screens has proliferated, and obviously children have access to iPads, phones as they get older. Certainly in the U.S., the idea of getting up early to go to school has become a big issue. And so, yeah, there's been a lot more interest in this area, and I think, one of the things that we've been getting to see, both within our own lab, but across the community as well, is, there's this importance of sleep as acting as a regenerative period. So you build up all these connections during the day, and then as you sleep, things that are important get saved, things that aren't get kind of cleared away, as well as all the byproducts of building that brain get cleared away, giving you sort of a fresh slate to start again the next morning. Certainly with respect to myelination, we've found in early kids that longer sleep, particularly overnight, so that nice long consolidated sleep, is beneficial for myelination and processing speed, which kind of then lay the foundation for longer term outcomes. In older kiddos, we see a direct relationship between longer sleep and performance on cognitive tests, particularly attention, executive functioning tests. And again, but the thing to remember is that it's not sort of one night that kind of, certainly the night before you have an exam is important, but in terms of brain development, it is sort of that routine basis. So one night that you don't get a lot of sleep isn't going to have a huge impact on you, but several nights with, or chronic sleep deprivation will have an impact. So definitely very, very important. Take those screens away. Let the kiddo fall asleep, and certainly again that nice long consolidated sleep. Parents like it because they get to sleep longer as well, but also good for their child's development.
Thank you. Okay, Dr. Matungi, one for you. It looks like a simple question, but it's probably loaded with answers here. So, is there a perfect diet for brain development?
Thank you, Dr. Green. It's a perfect diet for brain development. I guess a perfect diet for brain development will be a healthy, balanced, healthy diet. So the brain requires both macro and micronutrients, and we've been getting a lot of good information lately, not only from a scientific standpoint, but also from food intake, as well as guidelines on what is important for overall health. So the diet that provides you with all the required nutrients, both the micro and macronutrients, is definitely important, not just for brain development, but also for overall health, because just like the brain, all other organs are utilizing similar nutrients to ensure that you're healthy, and so as your brain performs as it meant to.
Thank you.
So a healthy diet with varied intake.
Thank you for that one. So now to Dr. Carvalho. I have maybe a more technical question for you as in your pediatrician head. It's around insulin and thyroxine. So are insulin and thyroxine resistance in the mother an early risk factor for fetal brain growth and development?
Hi, Dr. Greenstreet, and that is a great question, and one that we have a fair amount of information on. We know that mothers who have thyroxine resistance and infants who have less exposure to thyroid hormone or high exposures to thyroid hormone are very critical for early brain development. There are well-established clinical diagnoses like cretinism, which is associated with some of these abnormalities. So the simple answer to your question is yes, they can be a risk factor. Other hormones which can cause differential growth, which is well known, is conditions in the mother like gestational diabetes, which could be associated with insulin resistance, and sometimes also produce macrosomic or larger than normal babies as gestational outcomes. There's evolving data on this and glucose metabolism also affecting certain aspects of brain growth. But thyroxine and the importance of thyroid hormone is critical for early childhood brain development.
Thank you very much. Professor Dioni, there's been quite a lot of interest over the last couple of days of things like autism and ADHD. Especially ADHD questions have come in this morning after your presentation. So did you investigate children with ADHD? And if so, what did you find, if any differences?
Yeah, that's again a really great question, and certainly top of mind for a lot of our parents that are involved in our study. So one of the interesting things about our study design has been that we've been following kiddos, from obviously well before they would be conventionally diagnosed or show any sort of initial symptoms for either autism or ADHD. And so you get sort of this natural history where you'll actually follow along, and then children will begin to show early symptoms and then maybe go on to actual clinical diagnosis. In the case of ADHD, we have gotten to that point now. So, typically that is diagnosed early school age, 6, 7, 8 years of age. And now we can begin to look back. What were the early signs? What were the early presentations of those disorders? Now, we don't have a large number of those kiddos. 30 to 40 that have gone on to a clinical diagnosis. But one of the interesting things that we've begun to see is actually an overdevelopment early on, overmyelination in some of the areas that we see later on as being affected. So lots of studies of ADHD in adolescence and early childhood. Or later childhood, pulling back, we see even by age 1 or 2 years of age, we see an over-myelination in their parietal areas. So areas, again, associated with some executive functions that are impaired, so attention particularly. So they seem to be wiring up very differently very early on, and then that having later repercussions. So too early to tell on an individual basis whether you could actually predict that out, but certainly on a group level, we can begin to sort of distinguish early developmental differences that are going to be predictive or prognostic of later potential issues.
Great, thank you. Back to Dr. Mutungi. Again, a couple of questions coming up here about choline. So a really interesting one for you. Is choline affected by the type of delivery? So the levels of choline for the baby, any effect by the type of delivery?
Can you repeat the question?
So is there any effect, or is there effect on levels of choline for the baby by the type of delivery? So whether they're C-section or vaginal birth, is there any impact with choline development?
So choline, usually when the baby is born, the choline will come from the mother's breast milk. To date, there's not really data demonstrating that the type of delivery actually impact the breast milk levels of choline. Though I don't think that whether the baby is delivered C-section or by normal delivery would be receiving different amounts of choline from the mother, because no data is demonstrating that the type of delivery impacts the maternal incorporation of choline in breast milk.
Okay, thank you. And back to Dr. Covello. A really interesting question here from Malaysia. Is there any impact on local diets that can help with child brain development? So we've had a lot of discussion about individual nutrients, but what about the local diets?
So that's a great question, and I think that at the end of the day, when it comes to feeding children, bringing in the cultural aspects of diet are critical. I'm not incredibly familiar with the Malaysian diet, but having seen a few patients over the years, I'm happy to say that what provides good dietary lipids, both in quantity and in some case more specific phospholipids, are things like dairy, eggs, and meats. And I do believe that the Malaysian diet does allow for some of these things, particularly eggs and meat. I do want to raise the importance of fish as well, both during the early part of the first 1,000 days, that is during pregnancy, as well as later on in the introduction of complementary foods. So while dairy, which is milk, and eggs provide certain kinds of phospholipids as well as fats, fish has the unique advantage of having higher levels of a very important component, and that is DHA as well. And that's why there are very good dietary guidelines which encourage pregnant women to eat fish, but fish which is lower in mercury content, because we don't want high mercury levels in the diet of pregnant mothers. So low mercury fish is a great source of DHA, and from a Malaysian diet perspective, which I do believe is a country that consumes meat, I would say meats and dairy, eggs and dairy is a good source of inclusion to get dietary lipids, both phospholipids, and fish is a source of DHA.
Brilliant, thank you. We're almost out of time, so I'm going to give the final word to Professor Dione. We've talked a lot about executive functions, impact of sleep, impact of nutrition, and a few questions are saying, can you rank them? Can you prioritize? What's the most important thing for a child's brain development?
Oh, the most important thing is going to depend on who you ask, right? So, you ask 10 people, you'll get 10 different rankings on that. I think, it's very difficult to kind of put do this one, do this one, do this one. I think, as with everything, it is the composition, it's the complexities of how these things intertwine and work together. So, the standard answer that I give to every family is just love your child. If you do that, if you start there, everything else kind of follows along from it. So you'll nutrition falls along from that, reading, being with your child, playing with your child, bonding, all of those come together, which then ultimately lead to all those other functions. So just start there. Love your child.
Well, I don't think we can end on a better note than that. So I'd like to thank Professor Dione, Dr. Matungi, Dr. Carvello very much for joining us for this live chat. We have a lot of other questions that unfortunately we haven't had a chance to answer, but we will be putting the answer to those on the website after this social congress. So again, thank you very much, and we'll be back in a couple of minutes with the next talk around putting all of this into practice. So we'll see you in a few minutes.
Hi, I'm Dylan, and I'm going to be talking about how we can support executive functions through play in the real world and in the virtual world. Thanks for sticking with me. I know this is the last in a long line of talks. The way I hope to proceed is by quickly introducing myself and explaining why I'm so interested in the topic, talking a little bit generally about play for learning, touching specifically on executive functions in play, and wrapping up with some quick recommendations that healthcare providers can give to parents who want to be able to support their own children through play. All right, I am currently co-founder and chief learning scientist at a company called Cadaptive, which mainly provides machine learning, artificial intelligence, and rich analytics to educational software developers. my graduate work, my doctoral focus was game-based learning and next-generation assessment. Before that, I was a software developer for a little bit. Before that, I was an undergrad who worked on how games could help kids learn. And that was all because in 1985, I bought a Nintendo Entertainment System. With my own money, I spilled out a mountain of coins at the register, and the checker patiently counted them out with me. And it was with the Nintendo that I learned this: the Konami code. Up, up, down, down, left, right, B, A, start. There are many, many grown-ups who played the Nintendo Entertainment System as a kid who can tell you this code. It was originally a shortcut introduced by a software developer who wanted to be able to test lots of features in a game he was working on without having to earn them all. But it got left in, so when the game shipped, people discovered it, found out it was a really powerful cheat code, and liked it. A lot of other games used the same code as a cheat code, and so now it's sort of lodged in all of our minds. And it isn't just cheat codes that have stuck with us gamers. The other day, I was showing my children The Legend of Zelda, which is a classic, one of the all-time best video games. And I was pleasantly surprised to realize that I still remembered exactly how to find a secret staircase in the game by burning, the third bush up from the left on this screen in quadrant C8 or something like that. It's this stickiness of things we learn from games that we didn't even intend to be learning that first got me interested in the idea of games as a tool for learning. It turns out that lots of researchers have had similar ideas over the years. This is just a few of many academic books and articles that have been written about game-based learning, specifically digital game-based learning for this stuff. The earliest academic journal article I know of linking video game play to education is this one. And it came out in 1982, which is only 2 years after Pac-Man, the video game, shown at the right, was released in the United States. And given the length of the publication cycle for peer-reviewed research, I think that means that this guy Bowman must have written this article like a week after the game appeared. This is another classic video game. It's called the Oregon Trail, and the first version of it was actually written for mainframe computers in 1971. It was a text-only version. It got updated throughout the years. The picture here is from the 1985 version, and it got re-released in an iOS version. So as you can see, its popularity has endured through the ages. And, of course, we've been learning through play way longer than we've had computers. And play isn't just a human activity. We can think of dogs and cats playing, but it's been documented in all sorts of mammals, and also in birds, reptiles, amphibians, fish. Even invertebrates have been seen playing, specifically cephalopods. Now, evolution is pretty ruthless, so anything as widespread as play is must be providing some strong benefits. Play drives exploration of new environments, new materials. It provides for innovation, socialization, collaboration. In fact, one of my most frequent sayings is that play is the most powerful adaptation for learning in the history of the world. The American Association of Pediatrics has also weighed in on the benefits of play. I'm going to read a quick quote from their position paper on the topic. Play is essential to development because it contributes to the cognitive, physical, social, and emotional well-being of children and youth. Play also offers an ideal opportunity for parents to engage fully with their children. Okay, so play is good for learning. But what about executive functions specifically? Well, researchers have demonstrated that playing even commercial video games that weren't designed to do anything other than let you pretend to shoot people can lead to measurable improvements in attention control, which is an executive function, even on entirely unrelated tasks. This is an example of something we call transfer. This is FAR transfer, actually. And that is kind of a holy grail in education. You would love to find some kind of educational intervention that can stick with learners even in other contexts. And play has been shown to be just such a facilitator of transfer. And it isn't just video games that do this. Even the simplest childhood pretend play can support executive function. I am not a little boy. I am a shark. Sharks swim around and eat fish. To remember these rules requires working memory, To adhere to them requires self-regulation, and to adapt when a friend announces that it's time to play checkers or to become airplanes requires cognitive flexibility. That's an executive function trifecta. I mentioned earlier that Kidaptive does advanced analytics for education, but we actually got our start back in 2011 helping parents support their preschool-aged children through play. Specifically, we wanted to tap into the power of play and leverage that parent-child activity to strengthen parent-child bonds. To do this, we created, among other things, an application called Learner Mosaic. It was intended to be sort of like a preschool teacher in your pocket. And what we wanted to do with it was provide offline play activities that you could do with your child. This example, called Cooking Up Turn Taking, is one that is intended to focus on the social emotional skill of taking turns. It's a playful interaction you can do with your kid. You can pretend to be cooking stuff, and you're sort of modeling turn taking with them as you do that. We also provided plenty of easy to understand articles about various aspects of childhood development. In this case, this is about color identification and how sort of subtle and nuanced it actually is. All of these tips, recommendations, and suggestions for activities were personalized. One of the ways that we personalized is by asking targeted questions about various facets of child development. This example asks, what does Sophia do when she picks up a book? And you, the parent, can choose from among 4 options. You could say, yeah, she turns it right side up. She doesn't always open the cover first. She doesn't always turn the pages from left to right, but she does tend to turn them one at a time. We would then take that in, and based on that and other evidence we had of Sophia's progress, we would provide a particular activity that was intended to be targeted right at the sweet spot for that particular child. So in this case, it's a book familiarity activity where you could help Sophia become aware of the sort of conventions of books as cultural artifacts. Another way that we would personalize is by providing digital games, simple digital games that the children could play. And as they were playing those games, we were actually measuring aspects of their cognition. This is an example called Fireflies. As you can see on this screen, there are 4 fireflies flying around, 2 of which have kind of an orangish hue. The main mechanic in this game was that you had to keep track of the fireflies that had special colors. Sometimes they were green, sometimes purple, sometimes orange, but not just the regular old white fireflies. They would fly around, but they would only glow intermittently, so you had to remember which fireflies were the special fireflies and track their movement across the screen. Now, it was adaptive. It was a computer-based test, essentially, so it started off with a single firefly and maybe 1 or 2 distractors, but it got pretty complex with 3 fireflies, maybe even 4 fireflies that were of the target color flying around in a cloud of fireflies, and you had to keep track of them. And then at a certain point, they would freeze. And again, they weren't colored at this point, and you had to tap the ones that you had been tracking, the special colored fireflies. From there, we would be measuring your spatial working memory. All right, so then after the kid has played that game, we can tee up a particular tip that has the parent just engaging the child in conversation about it. And of course, we could also provide activities that would build on that same working memory capacity, which is an aspect of executive function. The whole list of hundreds and hundreds of these tips, recommendations, activities, etc. It was all searchable, so you could look for particular skills or particular contexts like indoors or outdoors, or I only have 5 minutes, or hey, I've got 25 minutes. I want something with no materials, or I'm okay getting materials, that kind of stuff. Now, all of this was built to support parents in supporting their kids through play. So now we're going to get to the final section, in which I'm going to try to leave you with a couple of concrete recommendations for parents. 4 recommendations specifically. The first is play with your kids. It seems like a no-brainer, but there are, as you guys probably know, parents out there who just don't feel comfortable playing with their kids, or they see it as something that you could do with very, very young kids, but you should stop as soon as the kid can basically walk and talk. No. Intergenerational co-play continues to be important as long as your kids will tolerate playing with you, basically. My oldest is 10, so we're still in that sweet spot, but I can imagine in a couple years he might think I'm a little bit too old and boring to play with. Parents are the first and most important teachers and playmates for our children. we want that child-parent play to build that relationship and to fill the child with confidence and strength. The second thing I would say is let your kids play on their own too, without adults. Give your kids lots of opportunities for unstructured playtime. And by that I mean playtime in which it isn't some grown-up setting the agenda. So sending your kid to soccer practice is fine, but if there's an adult coach who's running all the drills and telling the kids what to do and breaking up the kids when there's disagreement and all of that, they're losing an opportunity to solve their own problems and to come up with their own rules and to negotiate with one another. Those are all really valuable things that you should be getting from play. So give your kids time for unstructured play. Now that can be alone, it can be with peers, it can be with video games, maybe not a ton of video games, but video games can be great. It can be with physical games like board games, card games, or just, locomotor play, letting them climb trees and run around in the field and stuff. The third is specifically about physical play. I live in Silicon Valley, where many children grow up with pretty full schedules, and they're shuttled around by adults, and they don't have much opportunity for physical play. But physical play is that's why kids get ants in their pants. That's why they get so sort of wiggly, is because they're primed to be running around and climbing and throwing things and dropping things and crawling. Physical play adds brain-derived neurotrophic factor, which stimulates nerve growth, and astrocytic glycogen, which can fuel brain cells during intense mental activity. And there have been studies that have shown that children and adults tend to perform better after exercise on a wide range of cognitive tasks, from memory tests to brain teasers. So, the short version, physical play is good for your brain. And finally, find the play in everyday tasks. As I mentioned, I live in a part of the world in which there isn't a tremendous amount of free time to let kids just go off into the field and play. So one of the things that I had to resort to with my children when they were younger is we would turn the kind of stuff we had to do anyway into play. If we had to go shopping, we'll make it a scavenger hunt. If we had to do laundry, there's no reason we can't be doing a little bit of basketball with the laundry as we're putting stuff in certain places. When we have to unload the groceries, that was also a nice. We had a little bucket brigade where one child would throw it to the next child, who would throw it to me, and then I would put it away, or we'd switch up those roles. The idea is to encourage our kids' natural impulse to see the world playfully, and then find ways to engage them, specifically in play that involves executive functions, play that involves self-regulation or working memory or cognitive flexibility in a variety of contexts. And what that does is two things. Number one, it facilitates transfer. Anytime we practice a skill in multiple contexts, our brain tends to be able to abstract out the particularities of the contexts and solidify the use of that skill across the contexts. Another thing that it does that's really nice is it builds in your children the habit of bringing executive functions to bear, which makes it more likely that the kids will do that on their own, spontaneously, later in life. And ultimately, that's what we want. We want to be building in our children the capacity to go and leverage their own increasingly powerful executive functions in the real world when we're not around. And that is all. Thank you guys for listening, and I hope you've had a wonderful conference. Hi.
So that's it. That is the end of our Congress, world's first Congress across social media on child nutrition, brain and cognition. So thank you to everybody that's joined us over the last couple of days and for the fantastic number of questions and engagement that we've had from you, the healthcare professionals. We have many questions I know that we haven't answered over the last few days, but we will be putting those answers up on the website in the next couple of days, so stay tuned for that. The last couple of days have seen an awful lot of information coming across to you, especially around the areas of executive functions. And I really hope you now appreciate the importance in executive functions for child development and learning. We heard from Professor John Colombo, who started off the first day, really what are executive functions. We can talk about them in terms of working memory, brain plasticity, and but we can make it much more simple than that. And actually, when we're talking to our parents, when we're talking to other healthcare professionals, we should try and talk about learning in more simple terms. But executive functions are these functions that underpin really how we learn and develop, and how we essentially act as humans, if I can quote Professor Colombo. And then we used to think that these executive functions developed much later, so when children went to school. But we had learnt from Professor Cuevas, actually this starts much earlier on. And some of the brain imaging studies we've seen from Professor Dioni also show that these functions start developing around the early months of life, not the early years of life. So we really not start to think about the impact of things like nutrition, things like the environment, play, as essential from the first days of life. And then, as often happens, these things can go wrong. So we heard from Professor Hooper about it's not the end of the world, that these things can go wrong, but there are things and actions we can put in place to ensure that these executive functions are brought back on track. When we turn to nutrition, we heard this morning from Professor Dioni, first of all, about the impact of nutrition on the basics of brain structure and function, and how he can use his MRI techniques to really explore the cellular processes in early brain development. And then from Professor Carvalho and Dr. Matungi about the importance of key nutrients like DHA, choline, lutein, and especially lipids, phospholipids such as sphingomyelin in the diet, and how these again play a key role in processes like myelination, which we heard from Dr. Schneider yesterday. So I would like to thank everybody for watching, and hope that you take these sessions and take this information and think about them, and hopefully they'll be useful to you in your clinical practice. We have a survey online, and we would love to hear your feedback over the sessions the past few days. We will look to do more of these sessions, so information on topics that you're more interested to hear about, please let us know, and we will be back to you live next year. So again, thank you very much from Wyeth Nutrition Science Centre and the world's first Congress on Nutrition, Brain and Cognition.